Okay, so what are the two problems in calculus that I've mentioned to you that are really central to calculus? What are the two? We've already done one. Sorry? No? The tangent line problem, who that? Was that you, Ray? Brandon? The tangent line problem, and this is the second one here, the area problem. So the area problem, sorry? Why is it taking so long? What's going on here? Okay, is this showing up or not yet? Okay, so you can see I'm having technical difficulties. Give me a minute here to fix this, okay? Okay, finally up on the air. Thanks to Bill Gates. Okay, so this is the area problem. So the problem consists of finding this shaded area underneath the curve. Okay? Now I've only shown you this quadrant here. It could be this one. It could be a little piece of it. Okay, it doesn't matter. But the idea is to find that shaded area there. Okay? And the reason why we need to find that shaded area, I shall leave for calculus next year. Okay? So if you take that, you should find out why you do things like that. Now, there are a couple of ways. Actually, there are many ways of finding the area in calculus. Okay? The way that we're going to study is by breaking that area up into a bunch of rectangles. Okay? Breaking that area up into a bunch of rectangles. And there are two kinds of rectangles that we're going to do. One's called the left boundary method, and the other one's called the right boundary method. So get this picture down, and I'll explain to you what that means, okay? Well, first of all, why rectangles? Why rectangles? Sorry? Manisha? Sorry? Of a rectangle? Far easier than if you were to put a polygon in there, for example. Right? Because what's the area of a rectangle? Yeah. Yeah, length times width, base times height, whatever you want to call it. Okay, it's really easy to find the area of a rectangle. When you do calculus, this might then become a trapezoid. Okay, so things get a little bit more involved because you want more and more accuracy. It's not because we want to inflict pain on you, but we want to do things more accurately. Okay, so take a look at those two pictures, and they are both of them have rectangles. Now notice the boundary points at the top right hand corner of every rectangle in the top picture. Do you see why that's called a right boundary method? Because the top right-hand corner is on the curve. Okay, as you can see there. Right? The top right-hand corner is on the curve, as opposed to the left boundary method. Do you see that? The top left corner is on the curve. You guys see that? Okay. Now in example 1, the top one there, okay, you're going to underestimate the area. Underestimate the area. Okay, as you can see, because if you want to add the yellow rectangles, okay, it's going to be less than the area that you really want. Okay, assuming you're trying to find the area from 0 to 2. Okay, 0 to 2. And then if you look at the left boundary method, okay, if you look at the left boundary method, then you're going to overestimate, as the picture shows very clearly. Okay, that if you look at the sum of the areas of the rectangles, it's going to be more than the area that you really need. Now, I think Kylie was asking me, what is this little thing here? Is that right, Kylie? Yeah. Okay. That stands for delta, and delta is the width of the rectangle. Delta. The Greek letter delta. Which words? In general, x-coordinate of right-hand corner is? No, we're going to work with constant deltas. In calculus, we'll make it variable. Okay? Today we do constant. Okay? Is I times 2 over 5. I goes from 1 to 5. I'm doing 5 rectangles in this picture. Okay? So the general idea is to do more and more rectangles. As you do more and more rectangles, what do you think is going to happen to the area? Yes. Oh, hang on, answer my question first. As you get more and more rectangles, what do you think is going to happen to the area? It'll get more precise. Thank you. It'll be more and more precise to the area that you want. Okay, to be more and more precise and get closer to the area that you want. Okay, you had a question? Which equation? I times 2 over 5, comma, I goes from 1 to 5. You're going to see this in a minute. Okay. Well, actually, let me explain what that is. Let's go through that. So everybody get the idea of the width? Everybody get the idea of the width of the rectangle? No, Kylie? It's this distance divided by the number of rectangles. So that from here to there, what's that distance? 2 minus 0? How many rectangles? 5, hence 2 over 5. Okay, so the width of each rectangle is 2 over 5. All right. Now, to try and explain this to you, okay, this is really crucial. This is crucial. I'm looking at the right boundary method. So if I look at the rectangles, the rectangles are numbered 1, 2, 3, 4, and 5. Those are your 5 rectangles. If I look at the x-coordinate of those rectangles, do you all agree that for the first one it's going to be the x-coordinate for the first one is going to be 2 over 5? I'm talking about the top right-hand corner. Do you guys agree with that? What's the next one going to be? Hello? Hello? Anybody home? I'm sorry. Okay, isn't there 0 here? Isn't the x-coordinate 0 there? If you add 2 over 5, don't you get 2 over 5? And then if you add another 2 over 5, what does it become? 4 over 5, and the next one? And the next one? And the next one? Isn't that what you get if you were to plug in I equals 1, 2, 3, 4, and 5? Okay, everybody got that? So that gives you the x-coordinate of the top right-hand corner. Why do we need that? Okay, so here's the reason why you need that. Say you wanted to find the area of the first rectangle. Okay, and I'll call that A sub 1. Do you agree that the area of that rectangle is going to be delta times the height of that rectangle. The height of the rectangle, which is this line here, is given by f of 2 over 5. The function value where the x coordinate is 2 over 5. Everybody see that? Yes? Valerie? Okay. And then Valerie, tell me what a sub 2 is going to be. The width is delta. The height is and then the next one's going to be 6 over 5. So do you guys know how to evaluate the height of the rectangle, right? You take its x coordinate and plug it into the f equation and you get the height. And the area of a rectangle is the height times the width. You guys got that down? Yes? Okay. Here's a generalization again. This is for the, actually this one is for the left boundary method. You might want to get this down, okay? So this one is left boundary method. Yeah, it is confusing if you don't pay attention and really follow what's going on, okay? That's why you'll have to watch this YouTube. That's why I'm recording this. So this is the right boundary method, left boundary method. What we just did was the right boundary. Okay, so again, there are two methods depending on which of the two corners at the top fall on the function. Either the right or the left. You need to know both. Okay, you need to know both. And then in calculus, we will do halfway in between, and then we'll tweak it and make it a trapezoid, and we'll do all kinds of gyrations on it, okay? All kinds of gyrations on it. Emma, question? So eventually what you're going to do is you're going to add up the areas of the different rectangles. Okay, you're going to add them up to get an approximation of the area that you really want. Again, it's an approximation. Okay, and like Ray was saying, that the more rectangles you take, the more accurate that approximation is going to be. Okay, so that's the idea. All right, let's work on this example some more. Here's some more math. Okay, so this one here, this formulation, is for left or right? Right boundary method. Okay, so again, I'm putting in both of them at the same time. You better keep your heads wired. Okay, if you don't, you're going to get lost or fall asleep. Okay, and then the area and summation form is, and we need to come up with that. Okay. So in other words, what I'm asking you to do is, for this particular one here, I'm asking you to come up with sigma, some stuff in here, some stuff here, some stuff there. Okay, remember sigma, all it means is a summation. Just means sum these things up. Okay, sum these things up. So spend a minute getting it down and then we'll review that. Okay, so what I have here is exactly what Kylie got. Okay, except instead of writing 2 over 5, I kept it as a delta. Okay, the only difference between what I have there. Okay. So what I want to do is I want to find the area of the 5 rectangles and I'm going to make a table. The reason why I like a table method is because I can change this to 10 for you. Then what are you going to do? If you keep it in a table, it's really nice and easy to see how you're thinking, how you're organized. Okay? So get this table down. This stuff here that is in red, leave this for tomorrow. We'll work on this tomorrow. Today we are doing only this table. Okay, only that table. So get the table down and I'll show you how to use your sexy graphing calculator, because that's what you can use on the test next week and make life really easy for you then. Okay? You guys got your graphing calculators out? Here's mine. And so what you want to do is in y1, you want to put 6 minus x squared. Okay, put that in y1. Let's got that down, okay? Okay, so the first thing you're going to do, actually what I should really have there is, yeah, I really need to put another column in here. I really need to put another column in there. No, I need to put another column in here, so let me just go do that, okay? I'm just going to do it by hand. So really what I want you to do is put another column in here that will correspond to the x-coordinate of the top right-hand corner. Remember what boundary method are we using, right or left in this one? We're using the right boundary method. So I want another column in there that gives me the x-coordinate of that. And there's a reason for that you'll see in a minute, okay? So when I equals 1, what's the x-coordinate? Sorry? Thank you. And then what you're going to do is you're going to find the function value at that point. So this is an easy way to do on the TA84. You go vars. Everybody following me? You know, why don't you watch me and then I'll give you time to plug and chug. Okay? Go vars, y vars, function. Since the function is in y1, I will select that. And I want to evaluate it at 2 over 5. Got that? You get 5.84. So that will go in here. Okay? Well, what you really want is you want the area of that rectangle. So the area of that rectangle is going to be 2 over 5 times the answer that you got. And you're going to store it in the A variable. I'll pause here for a minute so you get this thing, okay? So the width of the rectangle is 2 over 5. The height was whatever my answer came out to be. And I'm going to store the answer in A. The reason why I'm teaching you all this stuff is that you can see that if you have 10 rectangles to fill in, you're going to get a lot of things that you'll have to add at the end, okay? So instead of really writing everything down, you want to store it, store it, store it, okay, store it. So then put this in A, and the way I denote that things are in the A variable is I put a letter in a circle. That denotes that, hey, I've stored my calculation into the A variable. Guys with me on that? Okay. Now what you want to do is you want to do the next rectangle. And the x-coordinate of the next rectangle is going to be 4 over 5. And the way you do this on your graphing calculator is not do the whole process all over again. You do second, enter. Second, enter. And you change the 2 to a 4. Let's say that again one more time. If you do second enter, it recalls your previous entry. You do another second enter, it will go to the entry you had before that. So do second enter until you get y1 2 over 5. Change the 2 to a 4. Change the 2 to a 4. And then hit enter. Okay? And then go second enter, and instead of the A variable, you will put it into the B variable. I will be there in a minute. Let me just finish this. Okay? Guys with me on this? If you hit enter, the answer will go in the B variable. The one after that will go in the C variable, the D variable, and the E variable. When you're done with all that, you're just going to do A plus B plus C plus D plus E. And with the graphing calculator, this is a piece of cake. Okay? The only other reason why I'm teaching you this method of doing vars, y vars, is because if the delta was not constant but it was variable, like it might be 2/5, 3/5, 4/5, 7/5. 8/5, 9/5, 10/5. This method is a lot easier than if you were to just take a delta out, okay, and do that. So I prefer this method for general purposes, okay? All right, so I'll pause here for a minute for you guys to fill in the table, and then we shall compare answers. Okay, does anybody need help on this process here? So your homework tonight is going to be based on this stuff. On Monday, what's going to happen is that, guess what? We're going to make those 5 rectangles infinity, not even 10, infinity. Infinity. And then we're going to do some pretty sexy math to come up with some answers, okay? To come up with some nice answers on that. You guys got this down okay? Okay, so let me show you this article that I'm sending over, and it's on my Facebook as well. Man, I learned from the best. You know, you guys are the best, right? I learned Facebook shit from you. You guys learned math shit from me, so we are kind of even now. Oh, it doesn't let. Okay, it doesn't want me to take me to. Okay, let's see if I can get it out of here. Okay, so why the Chinese are flocking to the U.S. colleges? PRC, you want to pay attention because you're one of them. You are one of them. You're one of them. Okay, so listen up. Okay, so this guy who wrote that article, William J. Bennett, was the education secretary in George W. Bush's time, okay? George W. Bush's time. H.W.'s time, actually. So look what this is saying, okay? This passion for education starting at such an early age is powerful. After meeting with Chinese teachers, parents, and children, 3 differences were immediately clear. First, the children are better educated than American children in the STEM fields: science, technology, engineering, and math, which is what I've been saying all along. Okay. High standards and high expectations are the norm in China. Are the norm. That means everybody expects that. Admission, it's an exception. If you have a high standard, you get your ass kicked. Because the parents come down on you, okay? Parents come down on admin comes down on you, and say, hey, drop the bar. So I drop my pants. Okay? So I'm telling you that we are in a competitive world. You guys are just not getting it. Because if you don't compete, you die. It'd be Darwinism. Yeah, it's Darwinian stuff, okay? All right, you guys have time to work on this. I suggest you do work on it so that if you have questions, you get them resolved, because on Monday I move on.